Hello students, in the previous class we discussed about the acidity of the alcohols and carboxylic acids. Now in this video we will discuss about the basicity of aliphatic amines. So the general formula of the amines. So what is the general formula? R NH2. This one is the general formula. Now majorly the basicity or the basic strength of the amines. How to identify that? The group which is donate lone pair of electrons. Okay, here the group which is donating donate lone pair of electrons, lone pair of electrons. So the lone pair of electrons, more the number of donating nature, more will be the basic strength. So on the basis of this condition, so what we will discuss in this topic, so the group which is donate more effectively in the presence of plus I groups and minus I groups. Why? Because we are discussing about the applications of the inductive effect. In the basicity of the aliphatic amines also one of the application. So based on that condition, now the general formula for primary amine it is okay RNH2. Now one example it is general condition only RNH2 compare with the ammonia molecule. Okay, compare with these two. Then in these given compounds, so how to identify the basicity of the compound? So both are the basic compounds only. Both are the basic compounds, but which one is more effectively donate the electron pair? That is important. Here, just if you observe in this is the one alkyl group. This alkyl group role is donate the electrons towards this nitrogen, towards nitrogen. But compared to that condition here, so we can write this NH3, NH3 molecule like this, H, NH2. So now identifying this is the one hydrogen atom here attached to NH2 group. Now this one is neutral. What about this R group? This R group is electron releasing group. If electron releasing group always increases the electron density on the adjacent nitrogen atom. Then compared to this lone pair of electron, now this nitrogen donate the lone pair of electrons easily to others. So that's why here we can write the basicity of the primary amines always greater than the ammonia molecule. Okay, this one is the basic information. Then now what are the formulas here already we discussed. If a plus I group is attached to the given compound or amines, that is always directly proportional to the basicity. It is directly relation with the basicity. If any minus I group is attached to the given compounds or amines, now it is inverse relation with the basicity. Inverse relation with the basicity. So that meaning here basic strength, basic strength increases. What about in the second case? Basic strength decreases. So these are the general formulas. These are the two formulas. One is plus I and minus I groups. So by using these two, we can easily identify the basicity of the molecules. Now, one general example, in that. A, CH3, CH2, NH2. This is the one molecule, ethylamine molecule. Ethylamine. Next, B, CH2, CH2, NH2. Here one chlorine group is given. One chlorine group. Next, another one. C, CH2, CH2, NH2. Here another group is attached to that. That is O minus. Next, another compound. CH2, CH2, NH2. Here N R3 plus. So these are the groups present in the given amines. In these amine case, just identify in this. These groups alone, these all are the plus I group. This one is plus I. But in the second option, chlorine which is attached to the same ethylamine group. This is the minus I group. The next third option, one O minus attached to the same chain. This one acts as a plus I. Next in the option 4, NR3 plus is attached to the carbon chain, same carbon chain. This is always minus I group. Then in these given four conditions, two plus I groups, two minus I groups. So plus I always increases the basicity, minus I always decreases the basicity. It increases, here decreases. So directly we can write the most basic compound in this. Here plus I CH3 group, here O minus. So which one more effectively release electrons? O minus effectively release the electrons. So C is always more basic than A. C is always more basic than the A. Then next, further in these two minus A groups, which one effectively withdraws electrons? It is effectively withdraws electrons like this. Effectively withdraws electrons from the this NH2 group compared to chlorine. It is also withdraws electrons, but compared to NR3 plus, very less effectively withdraws. So next basic compound is B. Least one is the D. So this is the order for basicity of given four compounds based on the plus I and I minus I groups. So we can say that directly, if a plus I group is attached to given carbon chain, that is always more basic than the minus I group attached imines. Okay, this is the one type of order only. Okay, this is the one type of order. The next, another compound, simple one only, we will discuss. If a plus I and minus I groups attached to that, what happens? Next, CH3, CH2, NH2. This is the one group. Next, another one is CH3, NH2 given. This is the another condition. So in these cases, which one is more basic? So we can say directly, here one CH3 group is attached to only one CH3 group here. That one CH3 group is here. This is plus I group. Now in the above case, it is also plus I group. This group is CH3. This one is C2H5 group is attached to the NH2. So which one effectively release the electrons means this compound A. It is B. A is always more basic than the B. This is the order. The next, in another case, next one more example, simple example only. CH2, CH2, NH2, NO2 group is present. Next, in another case, CH2, CH2, NH2, hydrogen atom given. Okay. So in these two cases, now here NO2 group, here one hydrogen atom is present. So NO2 group acts as a minus I, hydrogen acts as a neutral. So neither lose nor gain the electrons, but minus I withdraws electrons or decreases the basicity like this. Reverse only it is withdraws electrons. So what we can say this by using this method, B is the neutral compound is greater than the compound A. B is more basic than the A. So this is the basicity of amines if plus and minus A groups are attached to the given amines. Next, another example in this. Now we will discuss very important basicity of the compounds. First case, in vapor phase. In vapor phase only. So in vapor phase, always the order very important, basicity order. Basicity order of amines. Tertiary is greater than, primary is greater than, sorry, secondary is greater than primary. It is greater than ammonia molecule. This is the order for which one? Basicity in vapor phase. So in this vapor phase, what happens here generally? CH3, CH3 group and CH3 bond CH3 alone pair. Next, CH3 and CH3 H alone pair. Next, CH3 and H here CH3. Next, H alone pair. So these are the four compounds. In these four compounds, so generally in vapor phase, what happens here majorly? This is one plus I group. This is also plus I. Plus I. How many plus I groups here? 3. In this case, 1, 2. Here only 1. So if number of releasing groups increases on the given amine, that basic strength increases more. Why? Because your tertiary is always greater than, secondary is greater than primary, primary is than ammonia molecule. In vapor phase, what happens generally in vapor phase? In vapor phase, inductive effect only influence on the basic compounds. The basic compounds. This point also important now. Okay, in vapor phase, only inductive effect influence on the basic compounds. This is for vapor phase one. Next, another second condition here. in solvent phase, or it is also called in liquid phase, both same only. So these two conditions also very important. One is a vapor phase, another one is a solvent phase. In solvent phase, basicity orders we will discuss. Basicity, first case, if R equal to CH3 group is present. Here we wrote here same like CH3 groups are same. Here also if R equal to CH3 groups present, now the order is always the basicity order. Secondary is greater than primary is greater than tertiary. Least one is the ammonia molecule. So this is the order very important. This one. Next, second case. If R equal to C2H5, other than the CH, more than the one carbon atom present in the given compound. Now the basicity order is secondary is greater than tertiary is greater than primary is greater than ammonia molecule. This is the another order. This one is the order for basicity of amines if R equal to C2H5 molecule. So now this orders very important. Then how to identify this basic nature of the compound is very high. So why the secondary is here always greater than the in the first case primary and tertiary. Here also secondary is more than the tertiary and primary. So these conditions alone also we will discuss next. Okay. Then first one, if R equal to CH3. Okay. First CH3 group is attached to the primary amine. What happens? The second one, CH3 and H one lone pair CH3. Next, CH3 and bond CH3 bond CH3. Here lone pair of electron. Now identifying this. Here this is the one group which is CH3 group which is attached to the nitrogen. This group is a plus side group. Then the presence of solvent means mostly the solvent is a water molecule. If this hydrogen form a bond with water molecule, here also that hydrogen attached to the water molecule. Here the nitrogen containing lone pair of electron attached to the water molecule. So in these cases, here majorly oxygen get the partially negative, this hydrogen get the partially positive. Here also oxygen partially negative, here hydrogen partially positive. Then here also oxygen partially negative, this one is partially positive. This is positive, it is also positive. So generally the dipolar molecule, here it is bonded with electropositive and electronegativity atoms in the given primary case. Same as like here also this hydrogen. This hydrogen bonded with the water molecule. A lone pair and the nitrogen again attached to the water molecule. Now here, this is the one plus I group. This is the another plus I group. Now coming to the tertiary group, plus I, plus I, plus I. But only one is bonded with the water molecule. Okay. Now in these three cases, in these three, here this is partially positive, this is negative. This one partially positive, partially positive, partially negative, positive, partially positive. Then what happens here in these three cases majorly? If R equal to CH3 means CH3 size is very small. If CH3 group size is very small, here two inductive groups increases the density towards nitrogen. At the same time, here hydrogen bonding also directly attached to this nitrogen. Here this lone pair of electron easily donates to others. So here hydrogen bonding present, at the same time inductive groups also present. So equivalent here two hydrogen bonds and two inductive groups equally present. So that's why secondary is always greater. Now if R equal to CH3 group means next primary is more basic than the secondary. Then we have to compare the primary and tertiary groups. In these two cases, combinedly, we have to explain the factors. Why? Because here more than one factor is influencing more than one factor. So what is that here? More than one factor influencing in this case. One is the inductive effect, another one is the hydrogen bonding. In the second case, secondary amine, both equal, two hydrogen bonds, two inductive groups. But compared to primary and tertiary groups, here which bond will dominates more? Hydrogen bonding only more dominates than the inductive effect. So hydrogen bond dominates more than the inductive effect. Inductive effect. If hydrogen bonding dominates more means next primary is more basic than the tertiary. So that's why only here gave that order. Secondary is always more basic than primary. Primary is more basic than the tertiary in presence of solvent. In presence of solvent condition, it is very very important. Here both effects equally affects on the secondary. Then compared to the primary tertiary, here plus A groups 3, 1 hydrogen bonding. Here 1 plus A group, 3 hydrogen bonds. Now in this kind of conditions, so we should comparatively explain the basicity of the primary and tertiary. So that's why here primary hydrogen bonding always more dominating than the inductive effect. That's why only here the tertiary group and primary is more basic than tertiary. Okay. The next, if R equal to other than the CH3 group is present, if R equal to C2H5 group, if R equal to C2H5 group is present, then what happens here? We will discuss now. Same kind of compounds CH3 and H. This one is the primary compound. Next CH3 and H. CH3. Next CH3 and CH3. CH3. So it is a tertiary group, it is secondary group, it is the primary group. Sorry, in this case, all are the C2H5 compounds. Sorry. C2H5. C2H5 compounds only. C2H5. C2H5. So this one. Okay. In these three cases, next, how to identify that given condition here majorly? Here also hydrogen bonding exists. Here also hydrogen bonding. Here also. Here also. So these are the hydrogen bonds. Now this is the primary, this is secondary amine. This one is tertiary amine. So in these given cases, then here also three hydrogen bonds present in the primary, but this group is bulky group. Plus I only, it is bulky. Here also this group is bulky group with plus I. Here also this one is plus I group. Two hydrogen bonds equal. Here one hydrogen bonding. This is also plus I. This one also plus I. This one also plus I. If attacking of a water molecule in the C2H5 group, the bulkiness increases more. So that's why here secondary condition, if you observe, it is two hydrogen bonds, again same, two hydrogen bonds equal to two inductive groups. So it is always more basic. Another condition, secondary is always more basic. But comparatively, the primary and tertiary amines, in this, which group is dominating more? Inductive groups all are dominating more. Why here inductive group means steric hindrance. Steric hindrance, that means inductive effect dominating more than the hydrogen bonds. So always we should tell about the steric hindrance is always dominates more than the hydrogen bond in if R equal to C2H5 group present in the given amines. So that's why comparatively the primary and tertiary groups always tertiary is more basic than the primary. Why? Because steric hindrance it is a dominating more. So we should write secondary is greater than tertiary is greater than primary. Now this is the basicity order in terms of solvent effect if R equal to C2H5. Okay, students, in the next video, we will discuss mesomeric effect conditions. Thank you.